Hello everyone. Now we're going to be talking about experiment 2A, in which we are going to graphically determine the density of an unknown solution. So in experiment 1, you were able to find the density by measuring the mass and volume of a certain object. But now what we're going to do is compare the mass and volume ratios to determine the density, but we're going to use Excel for this purpose. So we're going to be taking two measurements in this experiment, just like we did in experiment 1. So the measurements that we're taking are mass and volume. So this should be familiar. But now, rather than an object, we're going to be measuring a solution. We're going to actually be measuring two different solutions and comparing them graphically. When we're recording the volume, we're going to be using graduated cylinders, and so we're going to record to the nearest 0.5 milliliters when we're using our graduated cylinders. So you should have one decimal place. Once you have all of those pieces of information, we're going to prepare a plot. So we're going to have mass on the y-axis and volume on the x-axis. And you're going to actually have two sets of data. So you're going to have solution A and solution B. Not necessarily the same labels or slope. I'm just generally showing you what this will look like. So when we make our plot in Excel, we can add a trend line. When we add a trend line, we will get an equation of a line that is y equals mx plus b. So what information do we get there? So the slope of our graph, which is going to be the m part of the equation, that tells us the density of each solution. We know that because slope is rise over run, so mass over volume. So that's the density. The y-intercept, so where the y-axis or where the line crosses the y-axis, so that's b, our b value, is the mass of the empty graduated cylinder. So we don't actually have to weigh the cylinder out. We will know the mass of the cylinder by graphing, okay? Because essentially, when there's no volume of our solution in the graduated cylinder, then the mass will just be whatever the cylinder is by itself. And we'll also know the identity of our unknown from the slope or the density of the solution. And you will be able to use the table provided in the text of experiment 2A in order to identify what your unknown is. Then we're going to understand how accurate we were, right? So how well we were able to measure these densities by comparing your individual data to that from the class. So we're going to compile a list of data for this experiment. And then we're going to calculate the average and the percent error. So the measured value is going to be the class average, and the true value is going to be from the table. So not a lot of data collection, but this will be a really good opportunity to explore how to use Excel. So if you don't know how to use Excel, there's a special Excel guide provided for you in the text of the lab manual or as a special attachment from your instructor, and you'll be able to use that to walk yourself through the instructions for how to make these plots. Have fun!